evening, 7th grade. So good to have you back. Today I want to teach you how to find the sample space for a compound event. So if you would, please make that the title on the next free page in your math notebook. When you have done that, mark the page with a pencil, close it up, put it off to the side, and I'll tell you when it's time to open it up. All right, before we get to the sample space for a compound event, let's talk about what that even means, shall we? So in probability, we talk about a simple event being different than a compound event. So take those two terms in now. A simple event is just one probability event. That's what we've been doing so far, like roll one number cube, flip one coin, spin one spinner, draw one card, so on like that. A compound event, which we're going to move on today, is like more than one probability event happening together, like rolling two number cubes, or flipping two coins, or spinning a spinner twice, or drawing three cards, or four, or five, or something like roll one number cube and flip one coin. Compound is two or more probability events at the same time. So far we've always done simple events. We're just going to do one thing and find its probability. Today we're going to start finding probability if you do more than one thing. So that's kind of what we're going on to. The other reminder I want to give you is how we found the sample space for a simple event. We're already done with that. So simple events, I encourage you to make a list of the sample space first. So as you'll recall, the probability for a simple event is the number of favorable outcomes out of the number of possible outcomes, which we call the sample space. And I encouraged you to do this first. Find the number of possible events first and make a list. Right? So if we're flipping a coin, I would say you make a list of possible outcomes, heads, tails, and whichever one you're trying to get, you circle. If you're going to roll a number cube, the possible outcomes, make a list of those first. 1, 2, 3, 4, 5, 6. There's your sample space. And then whichever ones you're trying to get, you would circle the favorable ones. If we were going to draw a deck, heart from a deck of cards, if you were trying to do that, in that case, your sample space, if we're only talking about the suit, like hearts, your possible outcomes are heart, diamond, spade, and club. That's your sample space. Those are the four suits you could possibly draw, and you just circle the one you're trying to get, and it's easy to find the probability. For compound events, this often leads to mistakes. Just making a list, it gets to be hard to do. So I'm going to teach you a totally different strategy for compound events. I'm not going to encourage you to just try to make a list. I'm going to show you something more careful than that. So let's do it. So quick one. What's the probability of flipping two heads on a coin, right? So if you were to just make a list, I'm going to do this wrong first. If I tried to use just a list, first of all, we would of course say probability of flipping two heads. So let me write that out. The probability of getting two heads is the number of possible outcomes. Nope, did that wrong. Sorry. The number of favorable outcomes out of the number of possible outcomes, or the sample space. Right? And if you just try to make a list, I'm going to do this and I'll come back to why it's wrong. So if I just try to make a list, well, what are my possible outcomes? And if I just list them and think, I would probably say something like this. My possible outcomes are two heads, two tails, or one of each, right? I think most people, when you first do it, you say, okay, that is my sample space, and my favorable outcome is two heads. So probably the probability is 1 out of 3. And that's wrong, and it seems right probably if you've never worked on a problem like this. Right off the bat, that seems like that should be it. So I want to teach you how to make today what's called a tree diagram when you're dealing with a compound event, which we are doing here. Two heads, so this is a compound event. Okay. Here's how a tree diagram works, right? So I'm going to flip two coins. So I'm going to look at my outcomes for flip number 1. and I'm going to look for my outcomes for flip number 2 separately. Okay, so I'm going to start kind of here. This is why it's called tree. I'm going to start over here, and I'm going to say, okay, so for flip number 1, I only have 2 possible outcomes. I could flip a head, or I could flip a tail on my first coin or my first flip, depending on how you're doing it, right? Now, after that, let's say I flip a head first, and then I'm going to flip my other coin next, right? So after flipping my head, my flip on my next coin could also have 2 possible outcomes, right? I could get a head, or I could get a tail on flip number 2. If I flip a tail first, then I'm going to flip my other coin. Same thing, there's 2 possible outcomes. Could flip a head, could flip a tail on coin number 2. And look what happens here. There's not actually 3 possible outcomes, like I guessed up here. There's actually 4. I could get heads, then heads, could get heads, then tails, could get tails, then heads, could get tails, then tails. There's actually 4 outcomes, not 3. And the tree diagram makes it really easy to find this, right? The 4 outcomes are what I end up with over here. 1, 2, 3, 4. So this one shows me like heads, then heads. This one shows me heads, then tails. This one shows me tails, then heads. And this one shows me tails, then tails. So what's my probability? Well, out of those 4 outcomes, only 1 is heads, then heads. So you don't actually have a 1 in 3 chance of flipping 2 heads. You have a 1 in 4 chance of flipping 2 heads. And the tree diagram makes that really clear. It's easy to see there's 4 outcomes, not 3. All right, let's try one together. Open up your math notebook and pause now and write this down. You're going to need a lot of space for your tree diagram. So what I would do, I'm going to write something here in between the problem and the tree diagram, but not real big. But you're going to need like a lot of space for this tree diagram. So be ready. I'm actually going to go to another page when I make it, but leave yourself lots of space at the bottom of that page for that. All right. So this is, let's take a few notes here. So first of all, let's note here that this is a compound event. And when we do a compound event, don't try to do this with a list. You're very, very, very likely to make a mistake with a compound event if you make a list. It's hard to think of all the possible outcomes, just like the heads, tails thing, we didn't think about certain ones repeating. Okay, so just like simple probability, the probability of getting a sum of 10 is the number of favorable outcomes out of all the possible outcomes, which we call the sample space. And this, we're going to use a tree diagram to make the sample space first. So it's very big sample space with a compound event. We're going to roll 2 number cubes, and we're going to have to list all the possible things that could happen. So a tree diagram, instead of a list in a compound event, we're going to make a tree diagram, and that'll really help. So I'm going to do that on the next page. If you need to pause here to write this down before I make the tree diagram, please do that. So here we go. So I'm going to make my tree diagram like this. We're going to roll 2 number cubes. So there's roll number 1, and there's roll number 2. Correct? So I'm going to start over here with neither. And when I roll number 1, there are 6 possible outcomes, right? On roll number 1, I could get a 1. Use your whole page to do this, as much space as you can take up. A 3, a 4, a 5, and a 6. I'm even probably going to run out of space with this, not enough space. So roll number 1, you have 6 possible outcomes, right? We can even write that down, outcomes. Now, let's say I roll a 1 first. Then I'm going to do roll number 2. Well, there's 6 more possible outcomes after the 1. I could get a 1, I could get a 2, I could get a 3, 4, 5, and 6. Right? So I could get a 1, then a 1, a 1, then a 2, a 1, then a 3, a 1, then a 4, a 1, then a 5, then a 1, then a 6. If I roll a 2, 6 possible outcomes. 1, 2, 3, 4, 5, 6. If I roll a 3 first, what could I roll on number 2? Well, 6 possible outcomes. 1, 2, 3, 4, 5, 6, and so on. Go ahead and write them all down. 4, 6 possible outcomes. 2, 3, 4, 5, 6. I don't even think I have space to do it, hardly. 5, 1, 2, 3, 4, 5, 6. And if I roll a 6 first, I'm going to have to go like over here. I could get a 1, a 2, a 3, a 4, a 5, and a 6. Lots of possible outcomes here. You can probably see how many, right? There are 6, 12, 18, 24, 30, and 36. So there are 36 possible outcomes here when I roll 2 dice. So how many of them are favorable here? Let me go back and see. I was trying to see how many get me a sum of 10, so I'm going to have to do some serious circling here. So to get a sum of 10, 1 plus none of these is going to get me a 10. If I roll a 2 first, a 2 plus none of these is going to get me a 10. If I roll a 3 first, 3 plus 6 is my max, that's 9. So if I roll a 4 and then a 6, I'm going to circle that one. That's a sum of 10. If I roll a 5 and then a 5, that's a sum of 10. And if I roll a 6 and then a 4, that's a sum of 10. So it looks like there's 3 out of 36 possible outcomes get me a sum of 10. If I hadn't made a tree diagram, I don't think I would have come up with the right probability. Here's what I would have probably done. I would have probably said, well, what could I could probably just list my possible sums, right? 2 is the lowest sum you can get, 2 1s. 12 is the biggest you can possibly get, 2 6s, and everything in between, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I would have said, oh, well, 10 is like 1 out of 12 possible outcomes. Oh, not even 12, because there's no 1. 1 out of like 11 possible outcomes. And it's not. It's actually 3 out of 36 possible outcomes. So making a list is likely to just cause a mistake. So I don't recommend it. So that, y'all, is how you make a tree diagram for compound events. How do you know if you have a good start on this? Can you tell me what a compound event is in probability? Can you explain why a list is not a good way to find the sample space for a compound event? And could you make a tree diagram to find the sample space for a compound event? If you can do those 3 things, I think you're off to a good start and ready to finish this up tomorrow. Be honest with yourself, though. If not, then I would watch this video again because I want you to come into class tomorrow really feeling confident and ready to go. Have a great evening.